The paper of the day is Generalized Isolation Level Definitions. Paper gives a precise definition of isolation levels, but does so in a way that is inclusive of optimistic and general multi-version concurrency control strategies instead of being dependent on locking. Where Berenson et al. Defined phenomena P0 to P3 in order to explain the ANSI-SQL isolation levels, that is degree 1, 2, and 3, Adia et al. Defined generalized phenomena labeled G0, G1, G2, whose definitions are independent of implementation strategy. Based on these generalized phenomena, they can provide portable isolation level definitions, that is PL, that accommodate all implementation strategies, not just locking based ones. Authors first built up a model of a database system and then defined different types of conflicts, that is read and write dependencies, as well as something called an anti-dependency that we'll get into, that can occur within the model. This leads to the general notion of a direct serialization graph, that is DSG for a history. The phenomena and isolation levels are then specified as constraints on the allowable graphs. A DSG has one node for every committed transaction. Directed edges between these nodes represent read-write anti-dependency conflicts. A transaction T2 depends on T1 if there is a path in the graph from T1 to T2. It directly depends on T1 if there is an edge from T1 to T2. In the description that follows, a delete is modeled as committing a special dead version of an object. To construct a DSG, start with one node for every committed transaction, and for all pairs of distinct nodes T1 and T2, add a read dependency edge from T1 to T2 if any of the following conditions hold. T1 commits a version xi of object x, and T2 subsequently reads xi. T1 commits a change, and T2 then performs a predicate-based read that the set of objects matched by the predicate are altered by T1's commit. Furthermore, T1 is the most recent transaction to have committed a change impacting T1's matches. Next, add an anti-dependency edge from T1 to T2 if any of the following conditions hold. T1 reads some version of xi of object x, and then T2 then commits the next version of x in the version history. T1 performs a predicate-based read. T2 then commits later some version, the next version of some object that would change the matches of T1. And finally, add a write dependency edge from T1 to T2 if T1 commits version xi of some object, and then T2 and then T2 then commits the next version of x in version history. The dependency types and corresponding DSG edges are summarized below. So the conflict names are directly write depends, directly read depends, directly anti-depends. And this graph, this picture shows the summary of portable ANSI isolation levels. So PL1, PL2, PL2.99, and PL3. The phenomena allowed are G0, G1, G1, G2 item, G1, G2. In G0, Ti's writes are completely isolated from the writes of other transactions. In G1, Ti has only read the updates of transactions that have committed by the time Ti commits, along with PL1 guarantees. For PL2.99, Ti is completely isolated from other transactions with respect to data items and has PL2 guarantees for predicate-based reads. For PL3, Ti is completely isolated from other transactions, that is, all operations of Ti are before or after all operations of any other transactions. Phenomenon P0 prevents dirty writes and is motivated by a requirement to be able to serialize transactions based on writes or to simply recovery from aborts. The latter reason is not applicable to all systems that may use other schemes for recovery. Portable isolation level PL1 provides for serialized transaction based on the writes disallowed by write cycles. So here is isolation level PL1, portable definition of read uncommitted. A write cycle is phenomenon G0. A history exhibits a write cycle if its directed serialization graph, that is DSG in short, contains a cycle, consists entirely of write dependency edges. Note that this definition neatly encompasses write cycles with more than two objects involved. The essence of no dirty reads without being overly restrictive on the reading and writing of objects written by transactions that are still uncommitted is captured by the phenomena G1, which is comprised of three subphenomena G1A, G1B, G1C. G1 subsumes G0, and PL2 is the isolation level that prohibits G1 and hence G0 also. Isolation level P2 G1A aborts reads. G1B immediate reads, intermediate reads. G1C circular information flow. Proscribing G1 is clearly weaker than proscribing P1 since G1 allows reads from uncommitted transactions. Our PL2 definition treats predicate-based reads like normal reads and provide no extra guarantees for them. We believe this approach is the most useful and flexible. Isolation level P2.99. This level, called repeatable read, provides less than full serializability with respect to predicates. Anti-dependency cycles due to predicates can occur at this level. Phenomena G2 item. Anti-dependency cycles occur when the THG contains a directed cycle having one or more item dependency edges. PL 2.99 forbids GA2 item anomalies in addition of G1 and hence G0. Isolation level PL3. When T1 performs this query, there are exactly two employees X and Y, both in the sales. T1 sums up the salary of these employees and compares with the sum of salaries maintained for this department. However, before it performs the final check, T2 inserts a new employee, Z2, in the sales department, update the sum of salaries and commits. Thus, when T1 reads the new sum of salaries value, it finds an inconsistency. This history is allowed at isolation level PL 2.99, but is forbidden at the isolation level PL3, which prohibits phenomena G2. G2 anti-dependency cycle occurs when a GHG contains a direct cycle with one or more anti-dependency edges. Mixing isolation levels. In a mixed system, each transaction specifies its level when it starts and this information is maintained as part of the history and is used to construct a mixed serialization graph or MSG. Like a DHG, the MSG contains nodes corresponding to committed transaction and edges corresponding to dependencies, but only dependencies relevant to a transaction's level or obligatory dependencies show up as edges in the graph. For example, an anti-dependency edge from PL3 transaction to a PL1 transaction is an obligatory edge since overwriting of reads matters at PL3. If an MSG is acyclic and phenomena G1A and G&B do not occur for PL2 and PL3 transactions, then a history is mixing current. Such a history provides each transaction with the guarantees that pertain to its level. Broader applicability. Author's approach is applicable to other levels in addition to the one discussed in the paper. They have developed implementation independent specification of commercial isolation levels such as snapshot isolation and cursor stability, and they have defined a new level called PL2+. The details can be found in Ardia's PhD thesis. The PL2+ is the weakest level that guarantees consistent reads and causal consistency. It is useful in client-server systems and broadcast environments.